Well, it's all ready to go back together. Turned out all right. You've got to be careful when cleaning up these nickel-plated boilers. If you're too enthusiastic, as I have been in the past, with the cleaning on the boiler, you can go through the nickel plate. So you need to know when to stop, basically. But yeah, it's all come up quite well. A couple of things left to do. I can get on with the reassembly, but there's a couple of things left to do. I need to source some sight glass because the little bit that was in there is really too short. And I've still got to make the regulator screw, but other than that, it's done. So I'm going to get on and put it back together now. Well, it's back together, and that was a lot more effort than I anticipated. What I hadn't realised was that the original crank pin, if I could find it, there we go. The thread on this was completely buggered up. I hadn't noticed that when I took it out, but it was, so I had to make a new crank pin. And getting all this aligned up was quite difficult. I think at some point in time, it's okay now, it's good now, but I think at some point in time, something around here got bent. Possibly, I think the con rod is very slightly bent, and this was all out of alignment, so I had to fiddle around with that a lot to get it to line up. But it looks pretty good now. I think it's okay now. What else? So we just left with fitting new sight glass. I need to acquire some sight glass of the right diameter before I can do that. But the next job will be making the regulator screw. Okay, so the next job with the Empco B-43 is to make one of those. And as you can see from my fingertip, it's very small. This is the regulator screw. Now this one is off of one of my Empire engines, a B-43, which happens to have exactly the same steam nut, the one that clamps the steam pipe to the boiler, as the Empco does. So I know that that is exactly what I've got to make. But I also know that whereas this has got like a red plastic, probably sort of Bakelite type plastic knob on it, I'm fortunate enough that I have a copy of Donald Stilson's excellent book on Empire model steam engines, and I know that the Empco one had a wooden knob, so the knob will be slightly different, but this part here, that's what we got to make. So to that end, I've drawn out a little sketch, and the fun part will be turning this 11-degree taper on the end here. This is a very, very thin piece of steel. It's only 164 thou in diameter, so but I think I've got a way of holding it in the lathe so that I can actually cut that taper. So let's get on with it. So to make this, then we need a piece of steel rod bar. I found this in my bar stock, which is perfect. It's obviously been used for something else, probably a mandrel, I expect. But this thinner portion of the rod here is only about 60 thou or so over what we need for the main portion of the regulator screw. So I'll get this chucked up using collets, and we'll turn. First thing we're going to do is turn this down to the 160. I'm going to go 165 thou. It needs to be 164, but that gives me a little bit of leeway, and we'll do it over the length which we need. The maximum length to the shoulder is 1 7/16, so I'll probably do it a little bit bigger than that, so that I've got, again, a little bit of extra to play with, and then we'll cut this off to length, and then the next stage will be turning the taper. Okay, so we're going to make, or attempt to make, the regulator screw. Now, I found this bit of bar stock in my stock of steel rods and stuff, and I've obviously used this for a mandrel or something in the past because it's already turned down, and it's quite close to dimension to what we need. So we've got a nice big bit at this end because that's going to be the head of the screw, but we need this bit turned down to 165 thou. We've only got to go, I think, 60 thou take off of this to get it down to size. And I'm going to do it over what I need and then turn it to a shoulder, and then we'll take it out and cut it off to length. And then we've got to find some way of mounting it to cut the taper, and then finally we'll cut the thread. That's the order of operations. So we'll get going on this. So I'm going to put a 10 thou cut on to start with, just to see how we're going. Oh yeah, that's cutting quite nicely. Yeah, it's cutting quite nicely. Right. Let's see what we're down to. Something like 40 thou, I would have thought. Yeah, so we've got to take off another 44, 45 thou. I'll bring it back when we're done. Right, I think we're there. Yeah, I think that's close enough. Pretty good for me. I'm not very good on tolerances, but that's not bad. I'll take this out, cut this off to length or slightly over length, and then we'll shorten that up. And then the next stage will be, say, turning the taper. So now we've got to turn the taper. Well, the little blank for the regulator screw fits absolutely perfectly in this 5mm ER16 collet, which is fantastic. That will hold it perfectly. Only one problem. I don't have an ER16 collet chuck on my lathe. However, what I do have is an ER40 collet chuck, which, amazingly, the little ER16 collet chuck fits in perfectly. Now, I'm sure the professional machinists out there are quite appalled by this, and I'm sure this is not the correct way to do it, but this is certainly the best way I've got of holding something this small. And obviously you're going to lose accuracy this way. One collet chuck inside another collet, not the best, but it will do the job for the little 11-degree taper that I need on the regulator screw. Okay, so obviously we've got to set the angle of the compound to 11 degrees. I've got my cheap digital protractor here. Basically this is how I do it. Very easy. Just make sure that everything is lined up nicely. Once you've got the angle set, you just tighten up these lock screws. Check again. We've moved it slightly. Do it again. Too easy to move this, that's the problem. Right, we've got it now. There we go. Now our compound is set to 11 and we're good to go. Now I've got my ultra high-tech power feed engaged here. Not really necessary, you could easily do this. Only very short length distance, I think 5/16 on the taper. But we'll use it anyway because it just makes things easier. And that is pretty much it. That is a nice taper. I think I've got a little bit further to go. I want a nice sharp point on it, but no, you get the idea. So that's our blank with its nice 11-degree taper on it. So the next operation is to cut the thread on there, and to do that I will swap out the ER40 collet on the lathe and put back the ER32 so we can mount the thick part of this, and we need to thread it all the way up. And yeah, it's 832 UNC, so that'll be fairly straightforward. And then the final thing to do will be to part this off to leave a little bit of a thin head, and I'll probably put a slot in it as well, because the top 3/8 of this will be the wooden knob that will go over the top there. So yeah, we're nearly there. Well, there's the final screw for the regulator. It's quite amazing how much work actually goes into making something like that, because it's tiny. I mean, there's my finger, you know. So I've made the wooden knob part, which will be up here at this end, and I've painted it, and it's drying. But yeah, so all that's left once that's done is the sight glass. Well, there you go. That's the final finished regulator screw with its little wooden handle. Turned out okay. Quite pleased about it. A lot of work, as I said, for something that's a relatively small part. So we'll pop that in, and I've got the glass tube now for the sight glass. I've got to cut a bit of that to the right length, and that's only a matter of doing that and getting a couple of nitrile O-rings for the gland sealing, and then we should be good to go and get it going.